Hey folks, today I have the pleasure to host for the second time Scott Haynes, but today is a special day because Scott is now a DevRel at Databricks. First of all, congratulations, Scott.
Thank you, sir.
Super excited to have you with us. And I think for those who didn't watch, who watched the last two videos I published, I talked about the multi-table transaction, and this feature relies on catalog-based commit. It's mandatory. But this concept is pretty new to me. So can you walk us through this concept in Unity catalog and maybe later for Delta tables as well?
Yeah, for sure. Yeah. I mean, so if you think about the catalog, right? The catalog has been one thing that people have kind of fought over the years, whether it was Hive and having problems with Hive, whether it was like, people kind of creating their own, catalog-esque type system on top of like HDFS back in the day. And now we've kind of moved to like this, kind of more of like a unified catalog like environment where you've got things like Unity Catalog that do all of your governance in like one spot. They manage like the ecosystem. They tell you where everything is, who has access, who shouldn't have access, what your columns are, why those columns should exist, why certain columns maybe don't need to exist because no one's using them, things like that. And so like with the catalog essentially becoming like more of like an engine on its own, you think about like the amount of effort it takes for people to say like, I've adopted a specific open lakehouse spec, right? Whether it's Iceberg, it's Hudi, it's Delta. That in itself is difficult. Then it's like, okay, well, we need an engine connector. This is a connector for Spark. This is a connector for Polars. This is a connector for XYZ other ecosystem. And that becomes a lot more difficult because we're taking all of like the onus on what should be correct. And instead of having like one place that's kind of the source of truth for all of that, we're instead saying, everybody figure it out, right? And that's a lot more effort for everybody to kind of maintain that. And then it also is problematic when you think about like moving, large specification major versions, right? So historically, right, it's like, we're moving from Delta, 2 to 3 to 4, et cetera. But we also have with Iceberg, right, moving from the V2 spec to the V3 spec that's been fairly difficult in the community. And now from V3 to V4, there's a lot more kind of work, that is also then it's like, oh, we just finished V3. Well, now we've got V4 coming as well. And those types of things, you're kind of always kind of chasing that next release that needs to happen. But when you have something like, the Delta kernel, for example, that's sort of the same sort of mental model, right? Where the kernel should take a lot of like the effort away from you as a, engine author that's creating something that is interoperable with Delta. And now with the catalog based commits, we have a different way of saying, well, this transaction completed correctly. I have recorded it. And now I'll make this new transaction visible to any reader. And that's something that I think is like a pretty cool thing, even if really, not a lot of people actually do see that as well. And because it's going to all happen behind the scenes, right? You've connected to Unity, you've connected to the Lakehouse ecosystem of your choice. This is all just kind of magically occurring for you, if that makes sense.
It's clearer now. And is there any specific thing to enable? Because I remember with the multi-table transaction, it was a configuration in the table properties like catalog-based commit enabled. Is it something different when it comes to Unity catalog, or what should I do to enable it?
Yeah. So I mean, with Unity, so I have a demo I can show after that kind of goes through the server properties. So because this is still kind of an experimental feature, you have to opt into this experimental feature as well in the server properties. And so we can take a look at like the Boolean value for that as well. It's really as simple as going from it's like, now it's true. Yay. Let's restart the server. And now like we can enable this new feature. And then on top of that, there's also a Delta feature that needs to be enabled as well, so that the tables that have the new support for catalog managed have the ability to actually write. And so it kind of requires both sides being turned on, right? If I turn on just the Delta side and the catalog's not ready for it, then, that's sad, right? It's like bad news bears. And then on the other side, right, it's the same sort of thing as well. So essentially two things have to be opted in. And then your tables no longer are writing only to the file system. They're writing first to staged commits, asking the catalog whether or not it's okay to essentially insert at that specific commit ID. And so it's kind of like a change to the concurrency controls that have been in place for a while in the Delta ecosystem. But now the catalog is the one saying, yes, you can do this, or no, sorry, you have to try again. And so it's just a different way of like opting into concurrency controls. We kind of already talked about this, like what is like the difference like between like, well, we brought up, I guess, two terms. And so we should really kind of talk about what those two terms mean, right? So you've got catalog managed tables. When we're talking about how this new catalog managed commits works with a Delta table. And so Unity Catalog provides us with something that we're calling like CCV2, which is a specification for catalog managed commits. And then Delta has essentially opted into that spec and said, okay, I know how this works. This is great. I'm going to just change my way of writing tables. And so if we get anything else out of this whole entire podcast, it's that the catalog managed tables use catalog managed commits from Unity Catalog, as in right now, Delta Lake and Unity Catalog are essentially the two partners that are making all this stuff work together as well. Okay. So we've talked a little bit about this as well. And so pretty much all of this kind of, if you were to boil down this whole topic into what is this doing, it's all about catalog coordination. So the catalog now becomes the source of truth versus, well, I wrote over here and you wrote over here. This should be in the correct order, but we didn't have the right, we didn't have the right concurrency control in place to make our writes, work as expected, right? Things came in out of order. Now with the catalog essentially being like the atomic arbiter of how your commits are actually recorded, you don't have to have those types of problems anymore. And so really, like, you think about this too, like there's three kind of main things, right? It's always discovery, because we're talking about a catalog, and the catalog is what allows you to see things. But also, like in the past with a lot of Delta Lake tables, people used to be like, oh yeah, my table is at this S3 path. And it's like, that's really cool. What if you move it? What if there's a V2? What if something changes? And it's like, well then you have to figure that out, right? And now with like the catalog based commits, you just have a catalog entry for a specific table. So say this is like your users table, or this is, an ecom orders table. The only real difference with all of this is that you now just have a table name. So it's really no different than having a managed table in Unity Catalog. Just the management and the coordination of your commits is now also, that is part of what the catalog is now doing as well.
And this
yeah, sure, you go.
And this is what will help, for example, if I'm using an external engine to be able to write into the managed Unity Catalog managed tables.
Yep. Yeah. So the commit API is also open as well. And so if you're an engine creator that wants to do something similar as well, and work with the catalog managed commits, then you can also extend the protocol as well. And so some of the things that people have wanted, like in the past, it's like, well, on commit, I want more metadata, right? Who was the user? Why did they do this? And a lot of that stuff went into like the Delta specification as well under metadata, right? And so it's like, well, if you have metadata that's going through in one path, is there a better way of doing it or a different way of doing that that's more interoperable, right? It's not necessarily tied directly to the Delta Lake specification, but rather it's saying, I want to commit this, table of some sort. And now the catalog understands a little bit more about what I'm attempting to do, why I'm doing it. Is this like a triage based job? What else is this? And so like having kind of an extensible layer in the catalog makes sense versus having to make sure that every single table specification is now opting in to do exactly the same thing. So we're saving people time.
That's right.
That's our goal, right? I'm like, fingers crossed, that's our goal. And then, the last thing too about this whole entire change too is that, for the longest time, Delta was essentially a file-based protocol. I wrote to the file system. All commits and everything else were managed through the file system. And then that put a lot more kind of complication on the actual client to make sure that everything is coordinated as it needs to be for the table to be correct. And now we're essentially adopting the same design that's been popular on like the Iceberg side since Iceberg essentially came out with the Iceberg REST catalog. And so now that, now both you can do basically the same thing on both sides, which is pretty good. So, as we're kind of moving towards like these next generations of like all of our open lakehouse formats, the catalog is something that's going to be very much, central to all of that. So moving on, we talked a little bit about reads. And so this is kind of more of for people who are excited about what changes. And not really a lot changes, right? So if we take a look at the left-hand side, this is a typical read with Delta. I have a reader. I say, I'm going to read the log. Where did I last read? Okay, great. I'm going to pick up from this checkpoint. What does that encapsulate? What has occurred and what Parquet file so I need to pull back in, right? And so if we take a look on the right-hand side, we've got like the log and we've got staged commits. We've got Unity Catalog. And so staged commits is essentially new to this whole entire, to the catalog managed commits. So, and we talk a little bit about that right now. We also can talk about that more when we go into the writes as well, because the staged committer is part of the write path as well. So if I'm a reader, I'm going to go and say, hey, Unity Catalog, I have this table. This is neat. I want to read from it. What can you tell me about it? And it's going to basically say, okay, I'm going to tell you exactly the same thing that Delta told you before, only now you're pulling that information, that metadata back from UC. And so Unity Catalog tells you exactly where the Parquet files live, why you should care about them, And then, is there any kind of like, is there anything else you should know about this as well? Like, were deletion vectors like, involved, anything else like that? And so you have the ability to basically read through the kind of traditional path, like through the Delta log. And you also have the ability to read into the staged commits that haven't been essentially rectified into the actual like core Delta log as well. And so you have this kind of two-phase commit path, which is interesting as well. If that makes sense over there. The big thing is the catalog is responsible for like the commit visibility, and you shouldn't care essentially as like a reader of a table whether or not it's going to be correct. Unity Catalog's responsibility is to make sure that the table is always in the correct order and that the data is exactly what you believe it should be. And so there's no more kind of guesswork. It's like, oh, did we have the right, I don't know, were we using, back in the day, there was like the S3 guard and other stuff like that. And then there was like the other, like, was the DynamoDB, like, assistant. I can't remember the name of it. I'm like, the thing.
Yeah. In AWS here, it's required the DynamoDB to be able to orchestrate writing from multiple engines. And I think with the catalog managed tables or catalog
managed commits,
yeah, it will get rid of this of the database.
Yes. Yeah. Then Unity Catalog already has a database. And so that ends up being what's essentially doing all the work for you as well. And so if you think about like killing two birds with one stone, which is kind of like a bad way of saying things, right? Because there's death involved. But if we think about this as like being something that's optimistic, right? We now do a lot more with less, which is really good. And so we take a look at the writes, right? Writes before, as we talked about with like the DynamoDB like committer, that is essentially the only thing that would help you to ensure that, write 1, write 2 happened in the correct order, because like this on the left-hand side is traditionally kind of like also like, this is Delta. If we want to think about this as like, Delta before, the catalog managed commits, then this is exactly what we see on the left-hand side, right? Really nothing changes, but, if I'm writing and you, if you're writing, if we both think that we're going to be essentially writing like, the 13th offset, then, that's great. If we do this incorrectly, then essentially we need something that's going to be there to ensure that we're going to have some sort of blocking right. And so if we take a look on the right-hand side as well, we still have the same type of interface that's there as well, right? Where it's like, if I'm going to go write, but I'm trying to overwrite what you wrote, then I'm going to have a failure. It's going to be like a concurrent modification type exception. That's great. Now Unity Catalog is going to be the one that's telling us whether or not that is, if I'm failing to write. Versus us having to think about doing that in some other way. Right? And so now there's one way to also think about how those concurrency controls are actually enforced as well. And so if you think about like governance as well, this is just another form of governance, right? This is write governance within Unity Catalog as well. And so, excuse me. I'm like I promised not to cough because of allergies, but here we go. I'm doing it anyways. It's a great Monday morning. So write coordination occurs in the catalog. Something new that's been introduced is essentially staged commits. A staged commit for me occurs in my file system. It can also occur on like an S3 path. Depends on if you're writing locally, if you're writing to, a fully fledged, environment. From the staged commits, I'm then asking Unity Catalog, take these staged commits and now go apply them. And so staged commits themselves become part of the Delta log over time as well. And so you don't have as many of like these like the temporary kind of missed commits that you would have in the past, where it's like we tried to write, we failed to write. Here's kind of like these like orphaned files that are sitting around in like S3. Now the staged commits themselves become part of like the Delta log over time. And that's all part of like there's server properties for a lot of stuff and for that. All right, so up next, we're going to take a look at the demo environment, which is called Unity Catalog Playground. And so without further ado, let me go and share the screen. All right, so what we're looking at right here is the main environment itself. And so if I just get rid of the Docker Compose and the server properties for right now, let's just go render the README. So Unity Catalog Playground. So this whole entire environment is essentially just an area where you can get comfortable working with Unity Catalog locally. And so in this case, there's really 2 steps to get the whole environment up and running. The first is to run Docker build. So let's open up a new terminal. So new terminal, get that opened up over on the bottom. Let's run the build. Make sure that Docker is running as well. Otherwise, this is going to fail because there's no Docker locally. So if you don't have Docker installed, you're going to need Docker Desktop. Or for me, like I use Kalima, which is the Docker alternative as well. So we've got everything built. So then our next step is essentially to just Docker compose up. So while that's starting, you'll see that we have Unity Catalog and the Miramo Spark. And for right now, I'm just going to go and take this link. So you can follow this link. We're going to open it up. And then we're going to get back to that in just a second. And so the first thing, though, we want to do, first thing we want to do is actually just kind of go through and see what is it that we're actually doing here, right? So it's great that we have the ability to run Unity Catalog locally, but what else is it that we want to do there, right? What's actually running behind the scenes? So right now we have this etc conf, and in there we've got server properties, and these are for Unity Catalog. And so we're talking essentially about the managed table features. So on the server, managed tables can be enabled. This is what gives us the ability to have catalog managed commits, which is what this whole entire podcast episode is all about anyways. And so as long as we have server managed table enabled, then we're all good to go. So now we're back and we're taking a look at the end result of us essentially running Docker Compose up. And so we're running Unity Catalog in one container, the Unity Catalog server more specifically, and then in the other container we're running Miramo Spark, and that's what's giving us this the UI itself. So I flip over to the UI and then take a look at like the actual catalog managed tables notebook itself. We'll see that it's essentially been mounted inside of the Miramo Spark container environment at the path essentially notebooks Unity Catalog Delta .py. This is also the same path that you'll find inside of the actual repository itself, just under like the Miramo Playground Notebooks Unity Catalog Delta. And we're running in Docker. We've covered the Unity Catalog server property, server managed table enabled true, when we were kind of running through what was in the actual environment itself. So I'm not going to go into that too much more other than to specify again that that's how we enable the catalog managed commits feature, which we're using on the Delta side as a catalog managed table. So switching back down, we've got Delta version 4.10, Unity Catalog version 0.40. This is for all of our assets that we'll be pulling into our Spark session itself. And you also see that we have a Unity Catalog server URL. This is pointing locally inside of our Docker network. So it's traversing the internal Docker network to the host name, Unity Catalog, which also represents our Unity Catalog single node server itself. The schema itself, we're going to actually use our own, but I've set this up essentially like initially so you understand essentially like what we have, what our capabilities are, right? So the main thing that matters is that our Unity Catalog main catalog, we're calling it Unity in this case. And this is what helps us actually configure our Spark session. So let's put that into memory and now move into the actual Spark configuration itself. So we're bringing in the Delta Spark package, which is essentially the jars that make us, make Spark extended to be able to work with Delta Lake itself. We're also bringing in the Unity Catalog jar itself, which enables us to be able to interoperate with the actual Unity Catalog server itself. And that's the way that we're going to be able to do our catalog managed tables. So we'll also see that we brought in our Spark Delta extension, the Delta catalog, and then over here we've set Spark SQL catalog for Unity to Unity Catalog Spark UC single catalog. And it is called single catalog because it's essentially representing everything within the nested tree that's underneath Unity within our Unity catalog. So you think about this as like say this is a developer catalog, you'd start working with the schemas inside of that developer catalog, but you wouldn't have access to all the different top level catalogs themselves. So we're using the same URL that we used before. We'll see we have no token, and that's because we're running locally. And in terms of governance, we don't need to have a strong position locally on our own governance because this is also just for a demo. So kind of main tokens, other things like that can all be vended through Unity Catalog itself. And this is not going to be that demo where we should. So also one last thing, we're defaulting our internal Spark catalog to Unity as well. And that isn't just in a way of simplifying, the first catalog that's actually loaded into memory. So we go to Spark config. We're going to be pulling in all the configurations we have from the above cell. and then creating our new Spark session. So this is going to load some jars. It might take a little bit of time. It wasn't that bad. So like 2.5 seconds or so, maybe 3. I didn't really read it that hard. Okay, so now we have a Spark session, which means that we have essentially like an entrance, like an entry point to be able to now use the new catalog managed tables. But the other thing we need too is essentially like a reason to be writing these tables. So the reason that I created for this actual environment is essentially like the notion of a pet rescue. So my wife and I love dogs. We've fostered dogs in the past, and we've been members of like the SPCA in California for a long time. So in this case, we've got a schema. I'm going to go create it right now. That's called Sanctuary. There's nothing too fancy here. We're essentially just creating an entry within Unity Catalog. And then we're just going to go and basically describe that schema itself. So we'll see that the catalog is Unity, and Sanctuary is that actual like internal schema namespace. So if we think about this as part of like our 3-part namespace in Unity Catalog, it's Unity, Sanctuary, and now we're going to be creating a table called pets. So in order to do that, we want to create a couple of just helper functions themselves. You can take more time with this. If you go into the actual environment itself, you can take a look through the notebook code itself. But really all we're doing is essentially creating a method that takes a data frame, returns a DDL from that as well. So we take a table name, the schema, which is actually the struct type of the data frame, and then any kind of properties that we want to add to the table itself. It gives us 2 different ways of creating tables. So let's go and load that into memory. And now we'll move over to essentially creating like a pet generator. So we're creating a data class called pets. We've got a pet UUID, it's got a name, it's got an age, and a flag to say whether or not it's been adopted. We would love all the dogs to be adopted themselves, but sometimes we've got some dogs that will hang out, and then we're going to bring those to foster fairs, etc. So let's load this into memory. And now we have the ability to go and create pets. And then also you can take this basically a list of our Python pets, and we'll create a data frame from that as well. And so all that stuff has been wrapped up nicely, so you don't have to worry about it. So let's go create some pets. So we generated some pets. This is really no different than how things are in the wild. People get pets. People have a reason to be able, to basically surrender a pet that then gets picked up by a rescue. And those pets then become pets for other people as well as they go through the adoption process. So litter one, we're just calling it. So if you think about 101 Dalmatians, anything else like that, right? Or if you've ever worked with dogs, if you've ever had a dog before and the dog's become pregnant, they have litters. And so litters are more than one dog. And in this case, we're creating, more than one here as well. So, but we're taking that first litter. This is going to be like, the first set of dogs that we bring into our sanctuary. And so we're going to go and basically create a data frame. We're going to take that schema, and then we're adding the actual feature itself. So Delta feature catalog managed supported. And then the UC schema is sanctuary, UC table is pets. And so the DDL itself, we're going to go create that using the code that we did before. And now we can go and print that DDL. And so I realize I've run through this before, so it's like there's no real surprise as we're kind of going through this as well. But when we print the DDL, we get a create table if not exists sanctuary pets. It has basically the same schema as our data frame for our pets themselves and our Delta table property. So now I'm going to go and create that first. Go create that table using our new method. And then I've already run this, so you have the output. But when I see an empty data frame, like seeing res show doesn't really mean anything. Essentially, it means that the create was successful. So you can basically clear that output so you can see it again. Okay, now we're going to go and write this table. So if I go and run this, we're running, we've written our table. So now we can go and see what those pets look like, right? So the pets are going to be kind of, they're going to be randomly generated every single time. You can create as many pets as you want. If you want to extend the pet generator to add more names, then you can do that as well. Sorry about that. All right, so Spark SQL will select everything we have from Sanctuary Pets. We've seen those. So now what we're going to do is we're going to take, so in the pet generator, I created what's called like an iterator, and we're essentially taking groups of a grouped iterator. And so if I think about this as like, we've got 100 pets, we want to then create batches of 10 pets, and then we want to write those into Delta. This is essentially just so we can create a number of transactions. So if we go run this, we're going to basically go take a look at each of the individual litters that we have in like our pets iterator, and we're going to write those to Unity Catalog. So writing those batches, batch by batch by batch. We'll see this there on the top as well. So if that little hourglass is moving, it means things are still happening. And you'll see we have 100 pets. So this is cool. And so like before we kind of move forward, this doesn't feel that different from, how we worked with Delta Lake before. Really, the only big difference is that we now also have Unity Catalog represented essentially as our, commit arbiter. And so anytime that we go and say, I want to go add, another batch of pets, I'm going to stage those commits, then ask Unity Catalog whether or not I can now still write those in the position that I expected. So say this was batch 10, I expect it to be batch 10. Then, Unity Catalog will tell me if my concurrency, if my numbers locally are correct for concurrency controls. And then if you want to be able to check and inspect any of the information on like the table itself, you can use the Spark APIs, but you can also use like the actual Unity Catalog client itself. And so I've added a couple, essentially the input-output to be able to go run more queries to find more metadata about this table itself. And so if I go in and take a look at this table, which is the Unity Sanctuary Pets, we'll see that it's managed Delta. It's got a storage location that's right now inside of our Unity Catalog table. And then underneath that, we'll see all of the different Delta features and properties that are enabled on the actual table itself. And you'll notice that we set one property, and then the catalog said, oh, well, these are the other properties that are important. I think this is actually like a really interesting kind of power move made by Unity Catalog and this feature itself. So no longer do you have to make sure that everybody's doing exactly the right thing. They have to bring a minimal subset of what they want to the table as they're creating new tables. The Unity Catalog will essentially add the additional features that are required for that table to work behind the scenes. And so this is like a big, big lift for anybody who's worked at Delta before. Okay, so outside of that, if we want to go and get like the table ID, storage location, these are required to be able to take a look at our commit history. And so we can get all of that just by using the different APIs that we talked about before, using the Unity Catalog client. So we'll take a look at that stuff over here, right? So all the information we need about our table itself is all located in here as well. Big one just being essentially the table ID and that storage location. So from there, we can then hit this curl. So this is still like a preview feature. The Unity Catalog APIs, and like the CLI itself, will be providing more and more details later as we go. But if I run this curl, I can get back essentially like the commit version, the timestamp, all the information that I would need about the table. And all of this transaction information is essentially what helps me to understand essentially, what's my local position? Can I write, or has that write essentially been written by a different writer? And therefore, I have to now get like the next identifier or anything else like that. So concurrency controls are now all essentially delegated to Unity Catalog itself. And so if we take a look, we'll see that we have essentially a table itself. We've got some staged commits. And then we have commit history as well, once that's actually been reconciled with Unity Catalog itself. And so aside from that, let's take a look as well at just like the history of the table. We'll extend this a little bit more so we can actually see our create. And so you'll see we had our create table, we had that litter one, and then we ran through the iterator to create a couple more batches. And so the Delta history function from Delta Table Builder, all that still works. So if you ever use like a Delta Table API, you're able to still read the history of the table just like you would before. And then you're also able to read the same information from this the commit API endpoint as well. So you have two ways of kind of looking at the history of the table itself. And that's pretty much it for now. So thank you so much for tuning in. And, we'll be bringing more and more Unity Catalog updates to you as we go. So thank you.
In Lake Cow. Rise data seas, lake flow, streams the flow. Iceberg and Delta Lake, tables aglow. Unity Catalog governs lake base, OLT base strong. Ginny text to SQL, Mosaic, and KI prolongs. Yusuf and Quentin, co-hosts light the fire.